When I'm about to do really hard math in creative problem solving, I drink Dunkin' Donuts coffee. It makes me think and act and mathematically problem solve so much better. Just brewed some upstairs in my house. Oh my God! Nailed another commercial. Oh, I don't know why Dunkin' Donuts doesn't sponsor me. They should. If only someone would tell them. I would be rich. Never mind. Anyway, welcome to CPS, Creative Problem Solving. I like to call it CPS because, well, I'm just lazy. CPS. Child Protective Services. I guess maybe I should just call it Creative Problem Solving instead of Child Protective Services. Alrighty, let's get started. Okay, all I'm going to do is kind of go through a couple of example problems of what you kind of could expect to see in class this year. And I got these problems from Crossing the Rivers with Dogs, which is the book we're going to use in class. Except I'm going to have to type them all out because we can't use books too much in class this year because it is coronavirus 2020. So anyway, we're going to just do these by hand. So it says, at the conclusion of a soccer game, whose each team includes 11 players, each player on the winning team shook the hands with each player on the losing team. Each player on the winning team, that doesn't say winning, that says winging. It also shook hands with the members of their own team. How many handshakes were there? Wow. Okay, so we have 11 players, and we'll call that the blue team. And we'll get the fuchsia team, the 11 players on the fuchsia team. So each one of these, so if you think about, let's talk about player one. Player one on this team had to shake hands with 11 players. So he had to shake hands 11 times. And then player two had to shake hands 11 times. So the first part about this is relatively easy. So from the losers and the winners, so if the losers shake hands with the winners, that's 11 losers shaking hands with 11 winners. But each one did it, so that's 11 times 11. That's 121 handshakes. We'll call them HSs for short. So far we have 121 handshakes. That's actually the easy part of the problem. The hard part of the problem is when these 11 players, we'll go to purple, shake hands. Now here's how it's going to work. If there are 11 players on the winning hand, let's take player one. He's got to shake hands with everyone on his team. So player one has to shake hands with every other player on his team. Well, he doesn't shake hands with himself. That would be stupid, right? So he has to shake hands with 10 people. So he has to shake hands with 10 people. Let me move this over a little bit. Okay. Now player two already shook hands with player one. Actually, player one shook hands with player two. So in effect, player two shook hands with player one. So he doesn't have to shake hands with him, and he doesn't have to shake hands with himself. So he only has 9 people or players to shake hands with. Player number 3 player 1 shook with player 3. When player 2 did it, player 2 shook with player 3. So in effect, player 3 shook hands with player 1 already and with player 2 already. So he only has 8 other people. And I think you get it. 7, 6. So player 4 has 7. Player 5 has 6. Player 6 has 5. Player 7 has 4. Player 8 has 3. Player 9 has 2, and player 10 only has 1. So if you add that up, 10 plus 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1, all those add up to 55 handshakes. So we got 121 and 55 for a total of 176 handshakes. That's how many handshakes. So if you got 176, congratulations, you rocked it. All right. I hate that color, by the way. I'm going to change the color back to fuchsia. It actually just shows up really nicely. So one elevator, so we can get on this elevator, we can get 20 students or 20 kids, children. Or on this same elevator, because adults are heavier, we can only get 15 adults. So here's the problem. Right now, we have an elevator that currently has 12 children on it. So 12 childs. So the question is, how many adults can I put on there? Okay, well, I could put 8 children on there. We know that. That's easy. If I wanted to, because I can take 20 children. So I already have 12. I can put 8 more children. But I can't put 8 adults because, remember, adults weigh more. So we have to go with the original premise, and that was that 15 adults must be the same as 20 children. Now, if I wanted to solve this for children, I'm going to go back to 15 adults. If I solve this simple problem for children, I divide it by 20, and I divide it by 20. Now, looking at this, if I put this in my calculator, 15 over 20, I would find out that one child is equal to 3/4 of an adult. Well, I don't have a space for one adult, one child. I have a space for 8 children. So if I take this equation and I multiply both sides by 8, so I multiply this side by 8, and I multiply this side by 8, I get 8 children. Now 3/4 times 8 is 6, so that would give me 6 adults. And that is the answer to the question. I have room for 6 adults. Pretty tricky. There are 8 more boys in high school in math club. Wait, there are 8 more girls than boys in high school math club. There's a total of 44 members. How many boys are there? How many boys and how many girls are there? So we know we've got, if I take the number of boys and I add the number of girls, I would get 44. So there's a strategy that we could go through and implement. There's a simple math way to do this one, but there's a strategy to go solve this one. And the easiest way to handle this would be, okay, let's say there were even numbers, 22 and 22. And that would give us 44. But we know we've got more girls than boys. So we have to increase this number while we decrease this number. So let's just do it by 2s. How about we go 20 boys, which would mean 24 girls. That would be 44 kids. But this is only 4 more, not 8 more. So let's try it again. Let's go down again. So I'll go down to 18, and I'm going to go up 2 on this one, 26. Now, that's 44. Is this 8 more? Let's see. Is that 8 more? 6, 8. Yeah, there it is right there. So there are 18 boys and 26 girls. That was pretty simple. All right, let me take a quick pause. So refreshing. Come on, that's a classic right there commercial. Short, sweet, and to the point. Nailed it again. All right, let's do this one. How are we going to do this one? 12 heads and 32 feet. That's what they noticed. How many of animals were ducks and how many... 12 heads and 30 feet. How many of the animals were ducks and how many work hours? What does that even mean? How many were cows? I don't even know what I wrote there. You know what it was? I was using voice recognition, and I don't think it picked up what I said. So I really want to know how many ducks there are and how many cows there are. So I hope you realize that, that this is the part where we're going to start. If I take ducks and I add the number of cows, I should have 12 heads. So if I take duck heads and I add cow heads, I should get 12 heads. If I add, and I should maybe put H here, and if I add duck feet plus cow feet, I should get 32 feet. All right. So how about we do this? How about we say there's 6 ducks? So we'll say ducks is 6 and cows is 6. That's 12. So that's 12. But how many feet is that? Well, that would be here 12 feet, and this would be 24 feet. So 12 feet and 24 feet would be 36 feet. So that's not quite right. We need less feet. Now, the only way to get less feet is to have less cows, because cows have 4 feet, ducks only have 2 feet. So I'm going to I'm going to increase the number of ducks. Maybe I'll go, I don't know, let's go to 8 ducks. And we'll go down here to only 4 cows, because that's still 12. Now let's talk about feet. 8 ducks would be 16 feet. 4 cows would be 16 feet. Oh, okay. That's 32 feet. There it is. There are 6. There we go. So there are 8 ducks and 4 cows. So if you take a particular 2-digit number, this should say reverse its digits to make a second 2-digit number and add these 2-digit numbers together, their sum, I got to stop using voice recognition, their sum will be 121. What is the original number? So 2-digit number, reverse its digits, their sum will be, so I can do 12 plus 21. But that's not even going to give me like a 3-digit number. That's only going to give me 33. So I need something that's going to take me over a 2-digit number. So I think I'm probably going to need more like 18 and then 81. But even that's not going to take me over. That's only what is that going to give me? 99? That's 99. So I guess I could do 19 and 91. That would be, what is that? That's 110. That's not enough. So let's go in the 20s. How about, so 21, that would be 12. That's not going to work. So I need something over 25. So how about 20, how about 27 and 72? That's not enough. 28 and 82. 28 and 82. That's 110. That's not enough either. How about 29 and 92? So that's 1. That's 121. So there's one. I think there's a couple others. There's got to be one in the 30s. Let's try 30. So we need a big number. Let's start with 39 and 93. 9 and 3 make 12, so that's not going to be it. So how about 38 and 83? 8 and 3 is 1. And then, yeah, that's 121. So there's another one. Let's try one of the 4s. So how about 47 and 74? Yep, that's 121. And how about one of the 50s? So that was 90, 29. This was 38. That was 47. So I'm going to guess this one is 36 and 63. Oh, I want to go to 50s, not 40, 30s. So that's too. That was small. So I'm going to go 56. So this goes up one, that goes down one. 56 and then 65. Oh, and that's 121. Oh, there it is. So there's four different sets of numbers. Any one of those 4 would have been correct. All right, that's it. That's the end. That's the kind of stuff, a little bit about what we're going to be doing this year. Can you figure out a way? Now, I'm going to teach you strategies for solving those. There were some things going on in my head I didn't really explain to you because you don't want to be in my head, that's for sure. When you don't want to be in someone's head. No, I'm just kidding. No more Dunkin' Donuts. All right, see you guys. Goodbye. No, really, bye. Go. Just hit the stop button. You better hit that stop.